Okay, so let's talk about probability and statistics. So why do we want to do probability and statistics in an instrumentation and measurements class? The reason is because there's always randomness in our measurements. And so it's also very easy to take lots and lots of measurements. So if you have lots of measurements of the same thing, you have to have some way to decide what the actual value or the most likely value, best value, something like that from all of those measurements. So just to start off with a couple of definitions, population is all of the possible measurements. Sometimes we know the population, like the population of the school is all of the students. Sometimes it's an infinite continuum, like a measurement. And the other thing we have is sample. So samples are representative subsets. So most of the time we're dealing with a sample of measurements. One way to look at our many samples is to make a histogram plot. So a histogram plot is a plot that shows how frequently a measurement comes up. So we organize the data, usually we sort it from smallest to largest, and then we decide the size of bins, and then the plot is how many times a measurement fell into that bin. So the plot is number on the y-axis, how many times that happened versus what happened. So you see this a lot on grades. So this plot over here is a histogram of our first exam where everyone did very well. And so you can see that everybody is above the C range. We've got most of the people in the top of the A range. This is another example of some measurements, and so they've made bins that are 5 degrees in size, and so if it's between these two, you count how many times it happens. So you have to analyze the data to make a histogram, but there are tools in MATLAB and Excel to make these for you too. Another way to look at a group of data is with a measure of the central tendency. And so we have several measures here that we're going to look at. The most common one is certainly the average or the mean, but we have other ones as well. So this is an estimate of the center or the most likely in some form measurement that we got from a group of measurements. The other thing we will look at is the distribution function, which is the shape. So if we know sort of the center and the shape, we can make a lot of predictions based on our data. So the first central tendency is the mean, also called the average. I'm sure you've done it before. You just add up all of the measurements and divide by the number of measurements. So the most important thing to see here is that we have different symbols that we'll use for the sample mean. We use X bar. So the bar is saying it's the average of the X values. And the population mean, we use this mu. So you'll see these come up in other formulas. So make sure you're aware of those. Normally when we're talking about the sample, we take small n, lowercase n number of samples, where the population, we have capital N is the population size. But the equations are the same. You just add them up and divide by the number. So average 96.2 on this set of data. The median is another way to look at the central tendency of the data. In this one, you list all the measurements, you sort them in order, and then the middle value is the median. So if there's an even number of measurements, then you average the two middle numbers to get the median. And what the median value tells us is if you're at the median, you have just as many measurements above the median as below the median. So people talk about median salary a lot of the times because that means that there are as many people making more than that as less than that. And it's different from the average in most cases. So here our average was 96.2, the median 97.53. The mode is another way to look at the central tendency of a group of data. And it's the one most often, it's the measurement most often measured. So it's the most likely if you want to look at the probability of a certain measurement, the mode tells you that number. And it's the peak in the histogram. So wherever we have the most values, this is the number of measurements at each value, and so that tells us the mode. And there could be more than one. You can have more than one peak, and you have to list them all. So here the mode in this data was 96.91. Once we know the central tendency, then we start to look into the shape of that histogram, and so the dispersion calculations are one way to say how spread out the data. Was it all very tightly measured, or was it a flat distribution of data? And so to start off with, that deviation is our first definition, and this is deviation of a single measurement. So we measured the same thing over and over again, and so it's slightly different than how we've used deviation already in this class. Here, deviation, DI, is the difference between the measurement I, the ith measurement, and the average. So this is, remember, the sample average x bar. So that's what we're using for deviation in this section of the book. And it's worth repeating, there are other definitions of deviation. When we did the deviation plot, we didn't compare it to the average, we compared it to the curve fit. So if we want to know how spread out our data, the average of the deviation, the mean of the deviation, is one way to look at it. Here we're going to average them, so we're going to add them up, all the deviations, and divide by the number of measurements. If the deviations are some positive and some negative, we don't want them to cancel out and have an average of 0. So for the mean deviation, we take the absolute value of the deviation before we average it. This measurement is less common than the standard deviation. Standard deviation uses the square of the difference to keep positive and negative values from canceling. So this is the definition of the population standard deviation. We use sigma for that. And we see we have the deviation here squared. So this is the population mean. This is the individual measurement. And we add up the square of all of those, divide by the number in the population, the number of measurements in the population, and then take the square root of the whole thing to get the units back to normal. By squaring this instead of the absolute value, if you have big numbers in here, then they get bigger when you square them. If you have small numbers in this, then they get smaller. So large deviations get weighted higher compared to the mean deviation calculation, and small deviations are less emphasized compared to the mean deviation. But this is called standard deviation for a reason. It's the one that we usually use. There's a little bit of a trick here. The sample standard deviation we call S compared to the population standard deviation, and it's almost the same. It's the square of the deviations compared to the sample mean over all of the samples, but they divide by n-1 here, where in the population we divide by n. So you have to be aware of this, especially if you're using a built-in function in MATLAB or on your calculator. You have to know if it's calculating and dividing by n-1 or n. If you're not sure, you can test it. You can do a calculation on your own by hand and compare it to the calculator and see what it does. Some calculators have a button for each. The reasons for this are just not, we don't get into enough detail to explain why this happens. I emailed the author of the book. He was my office mate, Tony Wheeler. When I used to teach at San Francisco State, I shared an office with him. And so when I first started teaching this class, I said, why? Your book doesn't explain it very well. Why is this? And he gave me this big long-winded answer, but really you have to go into quite a bit of math before you can explain why this is. So we'll just take it as given for now. Variance is just standard deviation squared. So there's a square root in the standard deviation calculations. If you take those out, you get the variance. Usually, depending on the field you're working in, things will be defined in terms of variance or the standard deviation. Don't usually use them. You usually use one or the other. So some filtering fields, Kalman filter starts with the variance. Other things start with the standard deviation. All right, so this is all pretty simple, but here's an example just to see it through. So here's a set of measurements, and they're sorted by from smallest to largest. So we measured 1, 1, 2, 3, 3, 3, 4, and 4. So the central tendency things, the mean, we add them up, divide by the number. We took 8 measurements, get 2.625 for the mean. The median, since they're already sorted by order, we find the middle. This is an even number, so we find the 2 in the middle, and we would average them, but they're the same. So the median is 3. For the mode, we look for the peak of the histogram, or whichever one had the most measurements. So we have 3 measurements of 3. And you can see over here on the histogram, there were 3 measurements. So it's the value, it's on the x-axis is the mode. So we get the 3 from here. It's not the 3 from here. If we had taken 10 measurements of 3, the mode would still be 3. It's this number. And the standard deviation, we take each measurement, subtract the mean, square it, and add all of those together, divide by n minus 1, and take the square root. And the variance is just the standard deviation squared. Well, that's the basics of some definitions of statistics, and we will look at some very basic probability calculations next, and then we will get into a little more applied towards measurement systems later on. So good luck with the quiz, and I'll see you in the next video.